This is R.D. Sharma Solution Class 12 Chapter 18 Maxima and Minima VSAQ. Very small answer question we are taking. Write necessary condition for point x equals to c to be an extreme point of the function fx. Now there are certain things you need to understand. Necessary condition, necessary, sufficient condition, necessary and sufficient condition. So if you draw a function or imagine a function, what is the extreme point? These extreme points are nothing but the critical points. The critical points are where the slope is going to be 0. Wherever the slope is going to be 0, those are the extreme points or the critical points. So you have fx, this one, you can just differentiate this f dash x and then equate it to 0. This f dash equals to 0 is the necessary condition. But since x equals to c, for the extreme point of the function fx at x equals to c, just replace x by c. That is going to be f dash c, which is equal to 0. So this f dash c, this is nothing but dy by dx. Again, extreme point or the critical points, whenever we have certain function, we differentiate it, we equate it to 0. Try to find out those points where the function slope is 0. And then those are the critical point. Then we check for the minima and maxima for all these points. That is what we generally do in maxima and minima and the differentiation. So the line which is parallel to the x-axis is actually the line which is having dy by dx equals to 0, that is m or tan theta equal to 0. So this is the line which you need to write. Write sufficient condition for a point x equals to c to be the point of local maximum. So as I just suggested that we have the necessary condition. Now we have the sufficient condition as well. So critical point or the extreme point, CP or EP you can call it. Now the necessary condition was the differentiation and then putting it to 0. You have the function fx, you differentiated it, you call it as f dash x, that is dy by dx equals to 0, and at x equals to c, which is given in the question, f dash c equals to 0 is the necessary condition. But this question is asking about the sufficient conditions. So this is one of the condition, but it has to accompany one more condition, and that condition will include the necessary condition. What is the necessary condition? How do you prove that certain thing or certain expression or certain value is showing the maxima or minima? Remember, when we used to get negative, we say maxima. When we used to get positive, we say minima. So we do the double differentiation. That is, if you have dy by dx, which is f dash x, d2y by dx2 is f double dash x. And at x equals to c, this becomes f dash c, this becomes f double dash c. So this f double dash c, as I said, f dash double dash c, if it is less than 0, this f double dash c or double differentiation is less than 0, we say it is maximum, greater than 0, it is minimum. These are the necessary and sufficient condition. So you just have to add one more line to the question number 1. If fx attains the local minimum at x equals to c, then write the values of f dash c and f double dash c. Now we have the function fx, original function, y equals to fx. dy by dx is f dash x, single differentiation, first derivative. At x equals to c, what do you do? It's f dash c, first differentiation. So in order to find out the critical point or the extreme point, then we say f dash x equals to 0 at a certain point, f dash c equals to 0. Now the local minimum, what is the local minimum? F double dash c, in minimum of course is related to the greater than 0 sign. Maximum is related to the less than 0 sign. So when we double differentiate it, at x equals to c, if it is greater than 0, it is minimum. This question is all about minimum, but I'm just saying that if the question would have been local maxima, then this condition you have written, f double dash c is less than 0. So in terms of words, you are going to write like this, f dash c greater than 0, less than 0. This is the difference between previous question and this question. Write the minimum value of fx is equal to x plus 1 by x, x is greater than 0. Now first thing is the fx, which is x plus 1 by x. Now the minimum value, for that you need to have the differentiation. F dash x, 1 minus 1 by x square. This is called the equation number 1. Local minimum, local maximum, f dash x equals to 0. We call it finding of the extreme point or critical point. 1 minus 1 by x square is equal to 0. 1 by x square equals to 0, x square equals to 1, x will be equal to plus minus 1. Now are we going to take both the values? No. Because x is greater than 0, we cannot take x less than 0, x equals, so we need to take x equals to plus 1 or 1. Next thing for minimum, we have to find out the double differentiation. So the single derivative has to be converted into double differentiation. 1 minus 1 by x square, the differentiation is 2 by x cube. I'll just change it. There is a slight change here. It's not 1 by x cube because the differentiation of 1 minus 1 by x square is not going to be 1 by x cube. It's going to be, if you take this x square in the numerator, it will be x raised minus 2. Minus 2 will come in front, minus 2 and minus 1 is already there, so it will be 2 in the numerator, and then n minus 1, so it will be minus 3, so it goes down. So 2 by x cube, 2 by x cube. What is x? X is equal to 1. So 2 by 1 cube, it is going to be 2. So x equals to 1 is the point, critical point or extreme point, and the value of the function at x equals to 1 is the 1 plus 1 by 1, that is 1 plus 1, 2. This is 2. This is your answer. Now in the words, you are going to write it like this. The same question now, we have to find out the maximum value. Now you are aware what you have to do. Previously in the previous question, we found x equals to plus minus 1. Remember? Same thing is going to come here, and from there the turn will be different. So first differentiation is f dash x, which is 1 minus 1 by x square. F dash x is equal to 0. So 1 minus 1 by x square is equal to 0. X will be equal to plus minus 1. So x is greater than 0. That means you cannot, no, it's not x greater than 0. Oh, there is a slight mistake in the question. X is less than 0. X is less than 0 because the previous question and this question will be similar. Okay, so there is a slight change here. I'm just apologizing for that. X is less than 0. So x is less than 0. We cannot take x equal to plus 1. We have to take x equals to negative 1 for that. So f double dash x now, it is the double differentiation we have already done. It is 2 by x cube. Now keep that x equals to negative 1 and you are going to get the negative value here. Negative signifies that you are talking about the maximum value. In double differentiation, we are not much worried about the value. We are more worried about the sign which is going to be coming. So f negative 1 is 1 minus 1 by, this is 1 plus 1. See, 1, if you differentiate this, see there is two things which are going to be changed here. So when you get it here, you just place negative 1 here. So negative 1 plus 1 by negative 1. So negative 1 plus negative 1 is negative 2. So this is negative 2 is the answer. Now what has happened? See, in the previous question you said, or we got 2 for the minimum. Here you got negative 2 for the maximum. So this is the water, moving uphill. That's not possible, no? It's just possible because the graph is like that. The graph can be because we are talking about local minima and local maxima. So this is how you have to write it. Write the point where fx equals to x log x. X attains a minimum value. X attains minimum value. So this is x log base ex. So the function or the original function is x log base. This is log base e. So x log base ex is what? See, fx is equal to, this is the first one, x log base ex. F dash x is the differentiation. Let us take the differentiation. So x log x is 1 by x plus log x, differentiation of x is going to be 1. 1 plus log x, it will be, f dash x is 1 plus log x. Now the second thing is, we have to equate it to 0. When we equate it to 0, it will be 1 plus log x equals to 0. 1 plus log x equals to 0 means what? Log x is equal to minus 1. Now the base is e. E raised negative 1 is equal to x. Remember, log base a b equals to c simply means a to the power c is equal to b. So e raised to the power minus 1 is equal to x here. X is equal to 1 by e. This is your x. X is 1 by e is what you got. But you are not going to stop here because we need to find out the minimum thing. For that minimum or maximum, we have to go for the double differentiation. And that double differentiation will keep this x equals to 1 by e value and then see what is the sign we are going to get. So y is equal to x log ex. As I am saying, double differentiation is necessary, but let me find out the value of y also. When you put x equals to 1 by e, the y value, because write the point where this question is asking about x and y point. So we are just completing this, just put x equals to 1 by e and that is going to give you y as negative 1 by e. So x and y we got. Because the coordinates are being asked. What are the points where this attains minimum value? 1 by e and negative 1 by e is the final answer. But the double dash or double differentiation is also mandatory, because minimum can be confirmed only by that. 1 plus log x differentiation is 1 by x. So x is equal to what? It's 1 by e. It's 1 by e, 1 by x. X is 1 by e. So it goes up. X is equal to e. E is a constant value. It's 2.7 something value. So it is greater than 0. Greater than 0 means you are going to get a minimum value. So this is the minimum value for you at 1 by e and negative 1 by e. Find the least value of fx equals to ax plus b by x, where all these variables are and the constants are greater than 0. A is greater than 0, b is greater than 0 and x is greater than 0. So the first is fx. Differentiate it now. I am doing the differentiation now. This is a, b by x is minus b by x square. This is the first differentiation. Next is you have to find out the local minima and local maxima. For that you need to put this equal to 0. A minus b by x square equals to 0. So a will be equal to bx square. X will be equal to x square will be equal to b by a. So x will be equal to plus minus under root b by a. So under root b by a you got, but the only thing is everything is greater than 0. X is also greater than 0. So you cannot have a negative value. So the negative value we are not going to take. We are only going to take x is equal to under root b by a. Negative under root b by a you are not going to take. Alright. So x equals to b by a under root is the value which is the value for which y has to be computed. But before that, f double dash x, we have to prove that you need a least value. So you are going to get the positive value here. F double dash x. The double differentiation is what? A is 0. So this is going to be 2 b by x cube. Double differentiation. So x equals to under root b by a you have to put here and then find out the value. So 2b by this x cube is, see, under root b by a is b by a to the power half. So when it goes cube, it's 3 by 2. b by a to the power 3 by 2. So this, you know how to solve this. You can just take these, with the negative sign in the numerator. Combine this b raised power 1 with b raised power minus 3 by 2. 1 minus 3 by 2 is of course minus 1 by 2. It will come down. A of course goes up. It's a denominator of the denominator, so it will be positive. So a raised 3 by 2. So twice a raised 3 by 2 and b raised 1 by 2 in the denominator. So this is the final differentiation, double differentiation you have got. But at what point? A is greater than 0 in the question, B is greater than 0 in the question. When they both are greater than 0, the whole equation is greater than 0. That is, you are going to get a minimum value, least value. And the final thing is, because x is already under root b by a, let's find out y value for that. Y is equal to a, this is a under root b by a plus b by under root b by a, and that will be twice under root ab, x and y. So these are the final values which you can get x and y. Okay, and this is how you are going to go about it, solve it. Okay, so y and x you have to find out, and this question we are going to take in the next discussion. Thank you so much.